Okay, 12.4, this is your very last lesson of the year. I want to find the derivative of a function at any point. So we've already done this on lesson 12.3. Hold on. And we use this equation, okay? And the derivative, basically, this is the notation for derivative, is f prime. That's derivative. Oops, let me switch. I can't spell. Let's try that again. Derivative notation when you see f prime. So we're basically going to do the same thing again. Okay, so whether I say find the slope at a point, so when you're doing basically f prime, that means you're finding a derivative, you're finding slope, slope of a tangent at any point, and you're also finding the velocity function. That's the first derivative. When you get into calculus, you learn about second derivatives that will find your acceleration. So for this, we're just going to go back and do the other way, and then we're actually going to show you another way, what's called the power rule. So we did this on the last one. This might take me up some space. So my limit as h approaches 0, we're going to plug in, let's see if I can do this, 2 times x plus h cubed plus 2 times x plus h squared minus 7 times x plus h plus 12, and that whole thing minus the function itself, plus 2x squared minus 7x plus 12. Sorry, I had to go in here. Let me see if I can shrink this part. No, not really. It's still making it all one. Got it. Over h. That gives me my limit as h approaches 0. This I might have to do in several parts. Is 2, I'm going to write this as small as I can, x cubed plus 3x squared h plus 3x h squared plus h cubed. If I were you, I would just memorize this. 1, 3, 3, 1. Starts out high, x cubed, x squared, x, no h to the first, h to the second, h cubed. And it's plus 2 times x squared plus 2xh plus h squared minus 7x plus h plus 12. Okay, I'm going to run a space. Let me add it on another screen. Okay, sorry I have to do this again. So my limit as h approaches 0, that was 2 times x cubed. Oh, I need to write smaller. Okay. Okay. X cubed plus 3x squared h plus 3xh squared plus h cubed plus 2x squared plus 2xh plus h squared minus 7x plus h plus 12. Geez, I don't even have enough room on here. Minus your original function, which is 2x cubed plus 2x squared minus 7x plus 12. Sorry, I just ran out of room. I'm going to have to write this smaller. So my limit as h approaches 0. Okay. Let's see how small I can write this. 2x squared plus 2x cubed, 2x squared h plus 6xh squared plus 2h cubed plus 2x squared plus 4xh plus 2h squared minus 7x minus 7h plus 12. That just minus sign gets distributed to all of these. So it'll be a minus 2x cubed minus 2x squared plus 7x minus 12 over h. Oops, I forgot the h up there. So this cancels with this. Negative 2x squared cancels with this one. 7x cancels with this one. 12 cancels with this one. And at the same time, I'm going to factor an h out of every one of these just to save some space. So my limit as h approaches 0 of h times, so if I take an h out of this, that gives me 6x cubed. If I take an h out of this one, that gives me 6xh. If I take an h out of this, that gives me 2h squared. If I take an h out of this, that gives me 4x. If I take an h out of this one, that gives me plus 2h. And then if I take an h out of this one, that gives me a minus 7 all over h. My h's cancel. And so now I can substitute 0 in for all of my h's in here, here, and here. So when I do that, that gives me 6x cubed plus 6x times 0 plus 2 times 0 squared plus 4x plus 2 times 0 minus 7, which means these all disappear, and I'm left with my first derivative is 6x, oops, sorry, not 6x cubed, hold on somewhere. That's a square. Let me go back and erase this. That was a square. I can't read my own handwriting. 6x squared plus 4x minus 7. Okay, I also forgot that it asks you to evaluate the derivative at 1. So when I do f prime at 1, if you substitute 1 in for my x here and my x here, you're going to get 3. If I substitute 4 in, I'm going to get 105. Okay, so on number 2, I want to find the derivative of 5x squared minus 10x plus 1. So that is my limit. This one will be a little bit easier than the other one. As, oops, not x approaches 0. As h approaches 0, so 5x plus h squared minus 10x plus h plus 1, that's the first part, minus the function itself over h. So my limit as h approaches 0 of 5 times my x plus h is x squared plus 2xh plus h squared minus 10x minus 10h plus 1 minus 5x squared plus 10x minus 1 over h. My limit as h approaches 0. Now I need to distribute these. I did that earlier where I distributed the minus 10 and the minus to all of those. So that's going to give me 5x squared plus 10xh plus 5h squared minus 10x minus 10h plus 1, oops, minus 5x squared plus 10x minus 1 over h. So my limit as h approaches 0, my 5x's cancel, my 10x cancels, and my 1 cancels. If you do not get these to cancel, these last 3 with 1s in the first one, you didn't do this right. And then I'm going to take an h out of each. So that's h times 10x plus 5h minus 10 over h. h's disappear. Let's shrink this a little. That gives me my limit as h approaches 0 of 10x plus 5h minus 10, which means now I can substitute 0 in for h, which gives me 10x plus 5 times 0 minus 10, which gives me my first derivative is 10x minus 10. Okay, so you may have noticed the pattern already that instead of doing the whole entire process, which you will have to do on your test when I say do it by the limit process, but when I say use the shortcut, you're basically using what's called the power rule. So if I have a function, f of x equal x to the n, and I want the first derivative, all that entails is taking that exponent n, moving it to the front, and then reducing whatever that exponent is by 1. So for example, if I have f of x, I'm just writing this bigger, equals x to the fifth, I'm going to move this 5 to the front and reduce it by 1 degree. So my first derivative is 5x to the fourth. Okay. So on 3, I'm going to change this to an exponential. So that entails me moving 7/5 to the front and reducing this by 1, which means I have 7/5 x. I have to change the 1 to 5 over 5, which gives me to 2/5. So my first derivative is 7/5 times the fifth root of x squared. Okay. On 5, I'm going to rewrite this as x to the negative 10, which means my first derivative is negative 10, x to the negative 10 minus 1. So my first derivative is negative 10 over x to the negative 11, which means my first derivative is negative 10 over x to the 11th. Okay, 6, my first derivative. If you have a 6 and you move the 2 to the front, you're just going to multiply. Now technically 3 is 3x to the 0 power. So when I move that 0 to the front and reduce it, it won't really matter. So if I do f prime, that gives me 12x, because anything times 0 is 0, so even reducing this down doesn't make a difference, so it's just 12x. So anytime that you have a constant here, the derivative of a constant is 0. So the derivative of a constant is 0. Okay, so on 7, I'm going to want to simplify this. So if my f of x is 10x to the fourth minus 6x cubed, you want to multiply it out because you need it as one expression before you find the derivative. Move the 4 to the front and reduce it. So that's going to give me 40x cubed. Move the 3 to the front, minus 18x squared. Okay. Over here, in order to not use, this is the power rule that we're using here. If you leave it this way, you'd have to use a quotient rule, which you're not going to do till calculus. But you can reduce it and get it to one basic polynomial to do this. So if I divide x into each one, my function is going to be 3x squared minus 2x plus 1. You're just dividing each one by x. And now I can find my derivative, which is 6x minus 2. Remember, the constant basically will go away because the derivative of a constant is 0. Okay, number 9. The distance a particle moves along a path is defined by d of t equals 6t minus 2t cubed plus 4, where t is given in seconds, the distance of a particle is given in millimeters. So if I want to find an expression for vt, so your vt is the derivative of that. So velocity is always your first derivative. So velocity is your first derivative. When you get into calculus, you'll learn about second derivatives, which is your acceleration. So my velocity is, if I have 6t to the first, that basically means I'm moving the 1 to the front, reducing it down to 0, and anything to the 0 power is 1, so that's 6. And then the 2t cubed we're going to move the 3 to the front, so it becomes 6t squared. Oh, sorry, it's a minus. I accidentally covered it up so I couldn't see, so it's a minus 6t squared. And then the last part, the 4, technically that's 4, let's use a t. T to the 0, so when you move the 0 to the front, you get 4 times 0 t to the negative 1, which doesn't matter because 4 times 0 is 0, so that goes away. So this is my expression for my velocity. If I want my velocity after 6 seconds, basically you just, plug and chug it in. So 6 minus 6 times 36, 6 minus 216 is negative 210 millimeters per second.